On the first item of the third test, we're asked to use the integral approach to find the internal shear as a function of position along the beam. In other words, we want V of x. And so we have a cantilever beam with a downwards distributed load, and that tells us right off the bat here that our boundary conditions are out at that free end. Well, let's see, our coordinate system is set up here. There's x, so this is x equal to 0 at the fixed end and x equal to 16 at the right end, and so the shear at x equal to 16 is equal to 0. There's no concentrated force there, only have the distributed force, and the moment is also equal to 0 out there. With the two force boundary conditions, we may not need both of those, but we'll see how this all plays out. And then we're going to go find our shear function by recognizing the differential relationship between load and shear, that the slope of the shear is equal to the intensity of the load. So derivative of shear, the first derivative here, the slope of the shear diagram is equal to the load intensity. The load intensity here is the value of our distributed load, however positive is upwards. So since the load is downwards, then we have to get that minus sign in there correctly, and there's your minus 1.5x squared. And so now we find our shear by integrating the load, and that'll be minus 1.5x cubed over 3 plus our constant of integration. That's a key thing. We got to have that constant of integration. We're going to find it or solve for it using our boundary condition. Right, so that's really our third step here. And so V at x equal to 16 equals minus 1.5 times 16 cubed over 3 plus c. That value needs to be 0, so therefore we have that c is equal to 2048 pounds. I know that because we have pounds per foot for the units of the distributed load, so when we integrate that by multiplying the dx, which has units of feet, pounds per foot times foot, we give the whole thing in pounds. So therefore our final answer is that V of x is equal to minus x cubed over 2, because 1.5 divided by 3 is 2, plus 2048 pounds.